everyone, welcome to my channel Chemistry is Fun. Today we will deal some topic about NEET 2025 chemistry. This is chemical kinetics part 1. Now see students, the branch of physical chemistry which deals with the rate at which the chemical reactions occur, the mechanism by which the chemical reactions take place, and the influence of various factors like concentration, temperature, pressure, catalyst, etc. on the reaction rates is called the chemical kinetics, because these factors which are stated just now do have some influence on the chemical reaction. The rate which is measured over a long time interval is called as average rate, whereas the rate which is measured for a very small time interval is called instantaneous rate. So we can say that the rate of reaction is defined as the change of concentration of any one of its reactants or products per unit time. So change in concentration we have to see for the reactants or products per unit time. We have to see average rate of reaction. Now if there is a change from substance A to B, so what we are considering, there is a common hypothetical reaction in which A is changing to B. In this case, the average rate of the reaction RAV can be given by decrease in concentration of A divided by time taken, or increase in concentration of B divided by time taken. Because A is changing to B, so the concentration of A will decrease and the concentration of B will increase with time. Here, this is the way we can denote. Within brackets, when we write A, it stands for molar concentration of A, and delta within brackets A stands for change in molar concentration of A. So average rate RAV will be minus delta A by delta T, which is also equal to plus delta B by delta T. Here A and B both are the molar concentrations. Delta A we are saying that is change in molar concentration of A, and delta B change in molar concentration of B. We can also say that delta A is equal to A T2 minus A T1. So when the reaction progresses with time, at time T1, A T1 is the concentration of A. At time T2, A T2 is the concentration of A. So delta A will be A T2 minus A T1, that is molar concentration of A at T2 minus molar concentration of A at T1, and delta T equal to T2 minus T1. So our average rate of reaction will be equal to minus delta A by delta T. We have to write it as molar concentration, minus delta A by delta T, that is equal to minus of A T2 minus A T1 by T2 minus T1. Okay. So here everywhere we have to take the molar concentration. So we write within brackets. Now if the same thing we say as per change in concentration of B, R average can be written as, this we are taking as R dash average. Okay. So as per change in concentration of B, R dash average equal to delta B by delta T, where B is the molar concentration of B. Here also that is molar concentration only, that is BT2 minus BT1. That is molar concentration of B at T2 and T1 respectively, and delta T will be T2 minus T1. So it is delta B by delta T, where B is the molar concentration of B. Now we will find that rate of decrease in concentration of A will be equal to rate of increase in concentration of B. So RAV will be equal to R dash AV. So it is minus delta A by delta T, where A is the molar concentration, will be equal to delta B by delta T, again where delta B is the molar concentration of B. Units are either mole per liter per second or mole per liter per minute. We can also have mole per liter per hour, mole per liter per day, mole per liter per year, like that. Commonly used ones, mole per liter per second or mole per liter per minute. So mole per liter per second or mole per liter per minute. So mole L minus 1 S minus 1 or mole L minus 1 min minus 1. Let us see a numerical which is related to this. Decomposition of N2O5 is expressed by N2O5 gives 2NO2 plus half O2. If during a certain time interval the rate of decomposition is 1.8 into 10 to the power minus 3 mole per liter per minute, this is the rate of decomposition. What will be the rates of formation of products during the same time interval? Okay. Now see, N2O5 concentration is decreasing. So with time, so delta N2O5 by delta T will be equal to half of delta NO2 by delta T. We are dividing by the stoichiometric coefficient of NO2, which is 2 here. That will be equal to 2, since it is half O2, it will be equal to 2 into delta O2 by delta T. These are all molar concentrations written in brackets. So delta NO2 by delta T will be equal to 2 into, because minus delta N2O5 by delta T equal to half into delta NO2 by delta T. So if half becomes 1, delta NO2 by delta T, that will be equal to 2 into delta N2O5 by delta T. Everywhere it is molar concentration, so written in brackets. So it will be 2 into 1.8 into 10 to the power minus 3, that is 3.6 into 10 to the power minus 3 mole per liter per minute. For oxygen, delta O2 by delta T equal to half into delta N2O5 by delta T. That is half into, for N2O5 by delta T, what was the value given in the question? 1.8 into 10 to the power minus 3 multiply with half. We get 0.9 into 10 to the power minus 3 mole per liter per minute. Now see, rate is always positive, therefore minus delta N2O5 by delta T is taken as positive. Everywhere you can see we have taken the positive value. Whenever I say delta NO2 by delta T or delta N2O5 by delta T, that is definitely the molar concentration. So while writing, we write them in brackets. Now next topic is instantaneous rate. That is the rate of change of concentration of any one of the reactants or products over a very small interval of time. So if we say that dx amount of A is transformed into B in a very small interval of time dt, then rate of reaction will be minus dx by dt for A, in terms of A. Okay. The rate of reaction at that instant is given as minus dx by dt. Because I know that in differential calculus, when delta t becomes very small and it approaches 0, delta A by delta t can be represented as or can be written as dA by dt. Now for a reaction, N1A plus N2B gives M1C plus M2D. Here R instant will be given as minus 1 by N1, because this coefficient is N1, so it will become minus 1 by N1 dA by dt equal to minus 1 by N2 dB by dt equal to 1 by M1. Here it is, coefficient is M1, so 1 by M1 dC by dt, that is equal to 1 by M2 dd by dt. So these are all molar concentrations and they are written in brackets. Okay. So everywhere we have to take, we are writing the concentrations in the brackets only. So here we get an idea about the instantaneous rate. Here we take very small interval of time dt. So I hope students you all could understand the topic which I discussed today. Thanks for watching my video. Please subscribe to the channel and share the video. Please share the video. Thanks for watching. Thank you.